Hello, good afternoon, students. So, in the last class, we have seen with respect to flow through pipes. So, we will continue that topic and we will see today pipes in series and pipes in parallel. And also, we will solve some numerical problems on that. So, I'm sharing the screen. I hope it is visible to you. I hope it is visible to you. If you're not, you just comment. You just drop a message in the comment box. In the last class, we have seen what you can say as pipes in series or compound pipe. We have seen all these things. So in today's class, what we will do is we will study about equivalent pipe. What do you mean by equivalent pipe and how it is defined? So equivalent pipe, as the name itself indicate, this is defined as the pipe of uniform diameter. So the diameter of equivalent pipe is uniform, having loss of head and discharge equal to the loss of head and discharge of a compound pipe consisting of several pipes of different length and diameter. So you try to understand what do you mean by equivalent pipe. So equivalent pipe is nothing but it is defined as the pipe of uniform diameter having loss of head and discharge equal to the loss of head and discharge of compound pipe consisting of several pipes of different length and diameter. As you know that in case of compound pipes, different pipes of different length and diameter are connected end to end. So similarly, the loss of it due to this that is equal to the loss of it due to equivalent pipe. Now what we are assuming let L1 equal to length of pipe 1 and D1 equal to diameter of pipe 1. Similarly, L2 equal to length of pipe 2 and D2 equal to diameter of pipe D. L3 is length of pipe 3 and D3 is diameter of pipe 3. Capital H is the total head loss and L is the length of equivalent pipe and small d is the diameter of equivalent pipe. Sorry for the inconvenience. Now L, capital L, that is length of equivalent pipe is equal to summation of compound pipes connected end to end, that is L1 plus L2 plus L3. So the total head loss in the compound pipe, neglecting minor losses. So we are very much interested in only major losses. So capital H is equal to 4 F1 L1 V1 square by D1 into 2G. That is loss of head due to friction in the first pipe plus 4 F2 L2 V2 square by D2 into 2G, loss of head due to friction in the second pipe, plus 4 F3 L3 V3 square by D3 into 2G, letting nothing but loss of head due to friction in the third pipe. Now assuming F1 is equal to F2 equal to F3 equal to F. What we are doing, we are assuming loss of head due to friction, we are assuming friction F1 in all the pipes. We are assuming the friction to be same. F1 is equal to F2 equal to F3 equal to F. Now we know that discharge is nothing but area into velocity. A1 V1 equal to A2 V2 equal to A3 V3 from content equation. But area is calculated using the formula pi by 4 into D1 square V1. Similarly, the area of second pipe will be pi by 4 D2 square. And similarly, area of pipe 3 will be pi by 4 D3 square. So your discharge equation changes in this way. Now V1 from this relation, what will be V1 equal to 4Q divided by pi d1 square. Similarly, V2 equal to 4Q divided by pi d square, and V3 is equal to 4Q divided by pi d square. Now what we are doing, we are substituting these values in the above equation. So your H will become 4FL1. In this way it will become, and your H is equal to 4 into 16 FQ square divided by pi square into 2G into L1 divided by D1 raised to 5 plus L2 raised to D2 raised to 5 plus L3 raised to D3 raised to 5. And the head loss in the equivalent pipe is equal to H equal to 4FLV square by D into 2G. Taking same value of F as in compound pipe, where V is equal to discharge by area, Q by area is nothing but pi by 4 D square. So it comes out to be 4Q by pi D square. Now your capital H will become 4FL into 4Q divided by pi D square raised to square divided by d into 2g. So if you substitute or simplify it, it will become 4 into 16 q square f into L divided by pi square into 2g d raised to 5. Head loss in compound pipe is equal and pipe is same, hence equating the equation. What we are doing, we are assuming that the loss of head due to friction in the equivalent pipe is equal to summation of loss of head due to friction in individual pipes. So your equation changes in this way. L1 divided by D1 raised to 5 plus L2 divided by D2 raised to 5 plus L3 raised divided by D3 raised to 5 is equal to L divided by D raised to 5. Or if you further simplify it, it will become in this way. It is almost same only. L1, L2, L3 L by d raised to 5. That is length of equivalent pipe divided by diameter of equivalent pipe. D raised to 5 is equal to L1 by D1 raised to 5 plus L2 by D raised to 5 plus L3 by D. This equation is known as Dupuit's equation. In this equation, L is equal to L1 plus L2 plus L3 and D1 plus D2 are known. Hence, the equivalent size of the pipe, that is the value of D, can be obtained. See here, if L is known to you, then you can calculate L1 M plus L2 plus L3 by adding all the three. Similarly, D1, D2, D3 is known. You can calculate the uniform diameter of the equivalent pipe using Dupuit's equation. Now we will solve a problem in order to understand it. Three pipes of length 800 meter, 500 meter, and 400 meter, and diameters 500 mm, 400 mm, and 300 mm respectively are connected in series. These pipes are to be replaced by a single pipe of length 1700 meter. Find the diameter of the single pipe. So what are the things given to you? Length of pipe L1 is given to you as 800 meter and diameter of pipe is given as 500 mm. So it comes out to be 0.5 meter. Similarly, length of second pipe is given as 500 meter and diameter D2 is given as 400 mm. So it comes out to be 0.4 meter. Similarly, length of pipe L3 comes out to be 400 meter and diameter D3 comes out to be 0.3 meter. Now, let the diameter of equivalent pipe equal to D. So we are assuming the diameter of the equivalent pipe to be D. So L divided by D raised to 5 is equal to L1 divided by D1 raised to 5 plus L2 divided by D raised to 5 plus L3 divided by D raised to 5. L, capital L is known to you. How you calculate capital L? Length of single pipe. It is given to you. 1700 divided by D raised to 5 equal to L1 is 800, D1 is 0.5, L2 is 500, LD2 is 0.4, L3 is 400, D3 is 0.3. If you do the calculation, D raised to 5 comes up to be 0.007118. If you simplify it, diameter of the pipe becomes 0.3718 meter or 371.8 mm. So now we will see flow through parallel pipes. Till now we have seen pipes in series. Next we have seen equivalent pipe. Finally we will see flow through parallel pipes. If the pipes are arranged parallelly, what will happen? Consider a main pipe which divides itself into two or more branches as shown in the figure and again joined together downstream to form a single pipe. Then branch pipes are said to be connected in parallel. The discharge through the main is increased by connecting pipes in parallel. See here, the diagram itself gives a clear uh, explanation about pipes in parallel. So when we say a pipes are arranged in parallel, if suppose a main pipe is there, if it is divided into two more branches as shown in the figure and joined together downstream to form a single pipe, then the branch pipes are said to be connected in parallel. If suppose branch pipe 1 is there and it is branch pipe 2, this is first a single pipe only. It is cut into two halves. After that, it is joined in the downstream. Then these two pipes are said to be connected in parallel. And the discharge of the main pipe can be increased by connecting the pipes in parallel. So it is a good method. The rate of flow in the main pipe is equal to sum of rate of flow through branch pipe. That is Q, capital Q is equal to Q1 plus Q2. The discharge through pipe 1 is Q1 and the discharge through pipe 2 is Q2. So your capital Q will become Q1 plus Q2. In this arrangement, the loss of head for each branch pipe is same. Therefore, loss of head for branch pipe 1 is equal to loss of head for branch pipe 2. What we are assuming, the loss of head in each pipe which are connected parallel is same. So what will happen? Loss of head due to friction formula is 4F1 L1 V1 square divided by D1 into 2G. Similarly, 4F2 L2 V2 square by D2 into 2G. If we are assume that F1 is equal to F2, then the equation changes to L1 V1 square by D1 into 2G is equal to L2 V2 square by D2 into 2G. So this is the equation for pipes connected in parallel. So you need to be very careful while calculating or solving the problem. Different cases have different formulas. Till now we have seen pipes when connected in series, they are different. Pipes when considered to be equivalent, the equation is different, and the pipes when they are connected in parallel, the equation is different. So we will solve a problem on it. What is the problem? A main pipe divides into two parallel pipe. A main pipe is there which is divide itself into two parallel pipes, which again forms one pipe as shown in the figure. What is happening? A main pipe divides into two parallel pipe, which again forms one pipe as shown in the figure 11.17. 11.17 is nothing but this figure. This figure. What we are assuming, a main pipe is there, which divides itself into two parallel pipes, which again forms a single pipe. The length and diameter of the first parallel pipe are 2000 meter and 1 meter respectively. Suppose a single pipe was there, it divides itself into two parallel pipes, into two pipe branch pipes which are then connected parallelly. The length and diameter of the first parallel pipe is 2000 meter and 1 meter respectively. The length is 2000 meter and the diameter is 1 meter, while the length and diameter of second parallel pipe are 2000 meter and 0.8 meter. Length of both the pipes is same, but diameter is different. Find the rate of flow of each parallel pipe. You need to calculate Q1 as well as Q2. If total flow in the main is 3 meter cube per second, capital Q is given to you. Total flow in the main is 3 meter cube per second. The coefficient of friction for each parallel pipe is same and it is equal to 0.005. What is given to you? Coefficient of friction for pipe 1 and 2 is same and it is equal to 0.005. So what are the things given to you? Length of pipe L1 is equal to 2000 meter. Diameter of pipe 1 is D1 is equal to 1 meter. Length of pipe 2 L2 equal to 2000 meter. Diameter of pipe 2 is D2 equal to 0 point meter. Total flow Q is equal to 3 meter cube per second. F1 is equal to F2 equal to F. It comes out to be 0.005. It is given to you. Next, let Q1 equal to discharge in pipe 1, Q2 is equal to discharge in pipe 2. So as per our definition, the total discharge in the pipe, main pipe is equal to sum of individual discharge through the pipes when they are connected in parallel. That is capital Q is equal to Q1 plus Q2. This is given to us 3 meter cube per second. Now using the equation for pipes in parallel, that is 4F1 L1 V1 square by D1 into 2G, it is equal to 4F2 L2 V2 square by D2 into 2G. 4 F is equal to F1 is equal to F2 equal to F 0.005 into L1 is 2000 V1 square divided by D1 is 1, 2 into G is 9.81. Similarly, 4 0.005 2000 V2 square 0.8 into 9.81. So if you see here carefully, 4 gets cancelled, 0.05 gets cancelled, 2000 gets cancelled, 9.81 gets cancelled. So the equation simplifies and becomes V1 square divided by 1.0. It is equal to V2 square by zero point 0.8. Or if we are interested in V1 square, V1, then it will be V1 square is equal to V2 square by zero point 0.8, or V1 is equal to V2 by under root 0.8, or V1 is equal to V2 divided by 0.894. Now we know that capital Q is equal to pi by 4 D1 square into V1, that is discharge equal to errant velocity, equal to pi by 4, diameter is 1 meter into V2, what you can say, V1 is nothing but V2 by 0.894. Similarly, Q2 is equal to pi by 4 D2 square into V2, pi by 4 0.8 square into V2, or pi by 4 into 0.64 into V2. So we are substituting the value of Q1 and Q2 in equation 1. What we will get, that is Q is equal to Q1 plus Q2. Q is 3, Q1 is this much, pi by 4 into V2 divided by 0.94 plus pi by 4 into 0.64 into V2. So if you do the calculation, V2 comes out to be 2.17 meter per second. So substituting the value of V2 in equation 2, V1 is equal to V2 by 0.894, that is 2.17 divided by 0.894. So V1 is 2.427 meter per second. That is the velocity in pipe 1 is more than the velocity of flow in pipe 2. Hence Q1 is equal to pi by 4 D1 square into V1, pi by 4 into 1 square into D1 just V1 just now you have calculated. So it comes out to be 1.906 meter cube per second. Now capital Q is equal to Q1 plus Q2. Using that relation, Q2 will be equal to Q minus Q1. That is 3 minus 1.906. So it comes out to be 1.094 meter cube per second. So this type of problems you can expect in exam and even competitive exams. You need to remember what is the equation for pipes in series, what is the equation for pipes in parallel, what is the equation for what you can say equivalent pipe. All these things you have to remember. So this is also one more problem which is asked in AMIE in December 1975. So what is the problem? A pipeline of 0.6 meter diameter is 1.5 kilometer long. So capital D is given to you. Capital D is 0.6 meter, and capital L is also given to us 1.5 kilometer. So if you convert this into meter, it comes out to be 1500 meter. To increase the discharge, another line of same diameter is introduced parallel to the first in the second half of the length. Neglecting minor losses, find the increase in discharge. If 4F is equal to 0.04, the head at the inlet is 300 mm. So before going to solve this problem, the diagram sketch, rough sketch is very important. If you see the rough sketch of this problem, what we are doing, in the first case, discharge for a single pipe of length 1500 meter and diameter 0.6 meter. What we are assuming, first you write down what are the things given to you. Diameter of the pipeline is capital D is equal to 0.6 meter. Length of the pipe capital L is equal to 1.5 kilometer. That is 1.5 into 1000. It comes out to be 1500 meter. 4F is equal to 0.04. Sorry, F equal to 0.01. The small h is 300 mm. What is small h? Head at the inlet is 300 mm equal to zero point 0.3 meter. Atmospheric head is 0. HF is 0.3 meter. HF is also given to as 0.3 meter. Head loss. Head loss is 3. Head loss is given to as 0.3 meter. Now you see length of another parallel pipe L1 is equal to 1500 divided by 2. So it comes out to be 750 meter. The diameter of another parallel pipe is D1 is equal to 0.6 meter. So this arrangement, this figure shows the arrangement of pipe system. In case first, that is discharge for a single pipe of length 1500 meter and diameter 0.6 meter. This head loss due to friction single pipe is calculated using the formula 4 FLV square by D into 2G. Loss of head due to friction is 0.3, 4 into F is 0.01, L is 1500 capital L, V square divided by 0.6 into 2 into G. So if you solve this, V comes out to be 0.2426 meter per second. Now discharge equal to velocity into area. Velocity is 0.2426 into area is pi by 4 into 0.06. So it comes out to be 0.0685 meter cube per second. So in the second case, what is happening? When an addition pipe of length 750 mm and diameter 0.6 connected between the last half length of the pipe. So if initially the pipe was this much, now what we are doing, we are adding one more pipe. Addition of pipe is done 750 mm length, diameter 0.6. As a result of which these two pipes seems to be in parallel. So let Q1 is equal to discharge in first parallel pipe and Q2 is equal to discharge in second parallel pipe. So if the pipes are arranged in parallel, we know that capital Q is equal to Q1 plus Q2, where Q is the discharge in the main pipe when pipes are arranged in parallel. But as the length and diameter of each parallel pipe is same, Q1 as the length and diameter of each parallel pipe is same, what is happening? Q1 is equal to Q2 is equal to Q by 2. Consider the flow through pipes ABC or ABD. Head loss through ABC is equal to head loss through AB plus head loss through BC. But head loss due to friction through ABC is equal to 0.3 meter given. So therefore, what we are doing, head loss due to friction through AB is equal to 4 FLV square divided by D into 2 into G, where V is the velocity of flow through AB. So it is equal to Q by area velocity. Q by area is pi by 4 D square. So it is the solutions 14 divided by pi into 0.36. Now head loss due to friction through AB. 4 into 0.01 750 4 q square 0.6 into 2.98 and 2 into 9.5 into 36. So it comes out to be 31.87 q square. Now the head loss due to friction through BC is given by 4 into F into L1 V1 square divided by D into 2G. So 4 into F is 0.01 into L1 is 750 0.6 into 2 into 9.81 into Q divided by 2 into pi by 4 into 0.6 because V1 is equal to distance by pi by 4 into 0.6 to square. So using this, if you substitute the value of Q comes out to be 0.0867 meter cube per second. If Q is known to you, increase in discharge you can calculate Q minus Q star. Q is 0.0867 minus Q star is 0.0685. So the answer comes out to be 0.0182 meter cube per second. So this type of problem you can expect in exams. It is somewhat complicated, but if you practice, you will be solving the problems easily. So before going forward, I just want to recall the things which we have studied today, starting with what you can say uh, flow through pipes we have started. After that, we have classified the loss of head due to friction in two ways, that is major losses and minor losses. and major losses are the losses which causes more severe impact rather than the minor losses. So the major losses are calculated using two formulas. One is Darcy-Weisbach equation, number two is Cheesy's equation, whereas minor losses are calculated using various methods such as loss of head due to sudden expansion of pipe, loss of head due to sudden contraction of pipe, bends in pipe, pipe fitting, and obstruction pipe. Different chances are there that the pipe may get affected to minor losses. So when we are dealing with major losses, the loss of head due to friction is calculated using the Darcy-Weisbach equation, which is equal to HF equal to 4FLV square by D into 2G. Apart from that, Cheesy's formula is also there. If cheese is constant is they given, then V is equal to velocity equal to CL to the root mi, where C is cheese is constant and M equal to A by 4. Yes, a D by 4, sorry, hydraulic mean depth. So we solved some problem on that. After that, what we did was we studied about minor losses in pipe, that is loss of head due to sudden enlargement, loss of head due to sudden contraction, loss of head at the entrance of the pipe, loss of head at the exit of the pipe, loss of head due to obstruction in the pipe, loss of head due to bends in the pipe, loss of head in various pipe fitting. So loss of head due to expansion formula is very simple and easy to remember. H equal to V1 minus V2 square by 2G. Similarly, loss of head due to sudden contraction formula is HC is equal to 0.5 V2 square by 2G. Next, we calculated the loss of head at the entrance of the pipe, which is given by HI equal to 0.5 V2 V square by 2G. Similarly, loss of head at the exit of the pipe is given by H naught equal to V square by 2G. Then loss of head due to obstruction in a pipe is calculated using the formula V square by 2G into A divided by CC minus A minus 1 whole square. Loss of head due to bends in a pipe HB is equal to KV square by 2G. Loss of head in various pipe fitting given by KV square by 2G. After that, we solved some numerical problems on that. Next, we studied what do you mean by hydraulic gradient line and total energy line. So, line joining the pressure head and the datum head is known as your total hydraulic gradient line, whereas the line joining pressure head, kinetic head, datum head is known as total energy line. Next, we studied flow through pipes. When the pipes are connected in series, it is also known as compound pipes. So the equation to calculate loss of head due to friction when the pipes are connected in series is H equal to 4F by 2G L1 V1 square by D1 plus L2 V2 square by D2 plus L3 V3 square by D3. After that, we studied about equivalent pipe, that is pipe having uniform diameter and length. So if the pipes are connected end to end, then you can calculate the loss of head due to friction using equivalent pipe. The length and diameter of these equivalent pipes similar to the addition of different pipes connected end to end. So this equation is also known as Dupit's equation. That is L by D raised to 5 is equal to L1 by D1 raised to 5 plus L2 by D raised to 5 plus L3 by D3 raised to 5. Finally, we studied about flow through pipes. So if suppose a main pipe is there, if it has two main branches, then and it is divided into two main branches, and again it is joined together, then the discharge to the main pipe Q is equal to Q1 plus Q2. So we are assuming that as the pipes are connected in parallel, the loss of additive friction will be same. That is 4F1 L1 V1 square by D1 into 2G is equal to 4F2 L2 4F2 L2 V2 square by D2 into G 2G. If suppose F1 is equal to F2, then L1 V1 square by D1 into 2G is equal to L2 V2 square by D2 into 2G. After that, we solved numerical problems on that. So this was somewhat complicated, but we were able to understand it. So this completes our flow through pipes unit. If you have any doubts or queries, you can just pin me and or drop a comment in the comment box, or you can contact me at nadim@university, or even you can contact me through my mobile number, that is 8553171859. I hope you are having a good time. We will continue in the next class. Thank you, one and all.